Hey guys, Darian Giuseppe here, back again with another video for the Key Concept series. In this video, we're going to tackle a question from Module 2 of Pure Maths Unit 2. It is on the topic of series, more specifically, method of differences. So without further ado, let's get into the solutions. So part 1 of this question is saying, use the fact that 1 on K minus 1 on K plus 1 is equal to 1 on K by K plus 1 to show that the sum from R is equal to 1 to N of 1 on K by K plus 1 is equal to 1 minus 1 on N plus 1. So they want us to use this fact to show that this here is equal to this. So what we would need to do, right? Remember, this is a question asking us to show. So anytime they're asking us to show something, I like to write down exactly what it is they're asking us to show so that I know what it is I'm working towards. So I would say RTS required to show that, and we write down what it is we want to show. The next thing, right, I would look at this side here. I would just put down this here. So let's show it here. So showing, right, let's write down the left-hand side here. But if you recall, they want us to use the fact that this is equal to this, right? This guy is equal to this guy here. So what we could do is we could replace this with this guy here. So let's do that, use the fact. So we could say this could be rewritten as this, using the fact that this is equal to this. So we good there. So we could rewrite this as this. But what you should be thinking, right, immediately from the time you see this can be rewritten as this, or this function here, the summation of this function here can be expressed in terms of the summation of the difference of two new functions here, right? Whenever we see that, it should be like an ellipse, because this is method of differences coming into play here. And for method of differences, the key thing, the next thing we need to do, right, is we need to write down the first two terms and the last two terms of the series, because what happens with method of differences is you have a set of terms will cancel out with each other and leave you back with hopefully these two terms here. So that's what we need to show next. From the time you see this summation here of the difference of these two terms, right, this here being expressed in terms of, right, the summation of the difference of two terms, that's what we need to do. So let's look at the values of K when K is equal to 1 and 2, and then when K is equal to N minus 1 and N, and when K is equal to N. So let's look at those values, right, for the series, and we will see a nice development taking place, right, with certain terms being cancelled off. So let's look at the first term when K is equal to 1. So when K is equal to 1, you put 1 here, and that's how you get 1 and 1 minus a half. Then let's look at when K is equal to 2. What you will get is, you put 2 here, so you get a half minus a third. And then we can put plus dot dot dot. You don't need to put the third term, fourth term, right? Time is equal to marks in the exam, so you don't want to waste time, right, doing all that. You just need first term, second term, and now let's go on to the second to last term, which is the N minus 1 term, and the last term, which is the N term. So when K is equal to N, you just put N here, or rather not N, the second to last term would be N minus 1, and you put N minus 1 here. So the minus 1 would cancel off with this 1 to leave you with 1 on N. So that's what we should have there. So you will get 1 on N minus 1 minus 1 on N. And then the last term is when we're looking at when K is equal to N. So let's look at that now. And this is what we get. And this is, right, so from here, we need to show this, right? Next thing we need to do, or next thing you will notice, is that certain terms will cancel off. This will cancel off with this, the negative a half with the positive a half. the negative a third will cancel off with a positive a third in here. Believe it or not, there is a positive a third in there. And then there will be a negative 1 on n minus 1 will cancel off with this positive 1 on n minus 1. And then you can see the negative 1 on n will cancel off with the positive 1 on n. And you see the terms that cancel off, a lot of terms cancelling off. And you will be left behind with 1 on 1, which is 1, minus 1 on n plus 1, which is exactly what they're asking us to show. So this is some nice developments here. This is the nice thing about method of differences here. So we can then, right, just cancel off these terms and show that it is equal to 1 minus 1 on n plus 1. And we could just tie up this question and just say, therefore, the sum from r is equal to 1 to n of this guy here is in fact equal to this. And that there is your solution to this particular question. So now, let's look at part 2. Part 2 says, deduce that the sum from r is equal to 1 to infinity this time. This question had r is equal to 1 to n. This one is infinity of the same function, 1 on k by k plus 1 is equal to 1. So they say deduce it. So let's, what should we do? We required to show this. Let's write down what they're asking us to show. Okay, so let's show it now. To show it, let's use the information from the previous part, right? When they say deduce, it kind of like hence, right? You want to use the information from the previous part. So because we know this guy here is equal to this, let's write it down. And also, what they're saying here, when n, because n here is in this part of the question, part 2, is infinity. What they're saying is that as n tends towards infinity, what will happen to this function, or rather the summation of this function, is that it will tend towards 1. That's what they're saying as n tends towards infinity. So we need to show that. So why this is the case, or why it will tend towards 1, is because, right, as n tends towards infinity, this guy here will tend towards 0. Because as n tends towards infinity, this here will, the denominator will become bigger and bigger. Infinity is a number we can't define it, right? It keeps on getting bigger and bigger and bigger and bigger, right? And with a fraction, as the denominator becomes bigger, the fraction itself, the entire fraction, becomes smaller. It gets smaller, lesser and lesser and lesser. And it gets so small that it can tend towards 0. So, in essence, right, as n tends towards infinity, this fraction here, 1 on n plus 1, tends towards 0. And because this tends towards 0, you are left behind with 1. Right? You're probably asking, well, what happens to the 1? As n tends towards infinity, the 1 isn't affected. The 1 remains constant. But this guy is affected here because this function here has n in it. Right? And we're looking at when n tends towards infinity. So therefore, we will be left, right? And we left with the 1, and we can safely see that as this, or we can safely see the sum, or rather, yeah, the sum from r is equal to 1 to infinity of this function here is equal to 1. We can safely see that in the end. So, guys, this is your solution here, right? Or rather, this is your solution here for question 1. This is your solution here for question 2, or question 1, part 1 and part 2, right? So these are your two solutions for part 1 and part 2. Guys, I hope you all understood this one. Like the video, share the video to a friend that you believe it will help, and subscribe to the channel, and I will see you in the next video.